I want to talk briefly here about the chemistry that is behind the two potato clock. So if you see a clock like this, it's got two potatoes, and you've seen different ones that come in little cups and things. I like this picture because it's very, very simple. But the idea here is that the electricity is coming from the fact that there are two different pieces of metal here. Looks like a piece of copper and a piece of zinc. And we need two of those because there's not enough voltage in one of these batteries. So we need two of them together in order to have enough voltage to light up that clock. Well, looking at it closely, the potato clock uses two different metals. Okay, so we can see that it's got copper metal and it has some zinc metal. And we can write down what we call the reduction potential reactions for this. So if we had copper ions, that they would have a tendency to pick up electrons, and because it's 2+, it's going to pick up 2 electrons and become neutral copper. And the same way, we could say zinc could pick up 2 electrons and become zinc metal. Now, doing some tests on this, people can find out that copper has a much stronger tendency to grab electrons than zinc. Now, where are these numbers coming from? They make a little battery, and they have a standard cell, and that's what they use as hydrogen and 1 molar hydrochloric acid. And they find out that this guy has got a positive voltage just because it is better at pulling electrons than this standard cell. But the standard cell is better than pulling electrons than the zinc. So we get a relative score for how much each of these wants electrons, kind of like a tug of war. Now, when we connect these together then in our cell, then what happens is we can see, well, they cannot both grab electrons. If somebody's going to gain electrons, somebody has to lose electrons. And we can see whoever has the larger voltage here, larger potential, that's the one that is going to occur as written. So one of the reactions that's involved is that copper 2+ picks up 2 electrons and becomes copper metal, just like it's written. But this one, okay, with the lower voltage, okay, it can't gain. It's going to turn out the zinc metal. We're going to turn this around. The zinc metal is going to have to turn into zinc 2+ and 2 electrons. So these are the two reactions that are going to occur right here. And if we put these together, we're going to just, I'll change colors. So everything on the left turns into everything on the right. And we can see what happens here. These 2 electrons are going to cancel out. So the overall reaction is going to be copper 2+ plus zinc metal turns into zinc 2+ plus copper metal. And somewhere along the way, we're going to find that we're going to have to define this value, n equals 2, and that's the number of moles, and it's the number of moles of electrons that happen to get canceled out when we put these two equations together. So just keep that in mind. We'll need that for AP equations later. So this is the overall reaction. Now, what is the voltage created by this cell? And that is, this guy here is going to be called the E0 reduction. So that means the voltage of this cell under standard conditions, which means everything is 1 molar. And if we add to it the E0 oxidation, okay, this number here that we have, that is the voltage if it was going to do reduction. So if we're going to turn it around like we did to have it do oxidation, then we have to change the sign. And then we're going to add those together, and that gives us the voltage of the cell. So we can see what we're going to get is positive 0.34 volts plus, we change the sign on this one, now it's positive 0.76 volts. So altogether the voltage would be 1.10 volts. And that would be the voltage we would have with that cell. Well, to run one of these little batteries, it takes out, probably about 2 volts. That's why we need to have 2 of these potato batteries, in series in order to get enough to run the little clock. And that is the basic stuff that's going on. So if we step back and look at this cell one more time, Then we say at the copper side, the copper is going to pick up electrons and become copper metal, and we know that that is reduction. So by convention, we call that the cathode. And I think of that as red cat, or the fact they both start with consonants. At the other side, then, this is going to be oxidation, and it's, losing electrons. And since it's oxidation, this is by, called the anode. And I remember that could say anox, or you can say that these both start with vowels. So cathode is where reduction occurs, anode is where oxidation occurs, and the electrons, we can see, are going to leave on this side. So the electrons are going to collect, down here inside the potato. We say that zinc metal turns into zinc ions, leaves electrons in here. So they pass through the circuit from the anode to the cathode, and they're going to pass through our clock and do some work. And that's the potato battery.